So this is about the SN1 reaction, okay. That is an example for the nucleophilic substitution reaction with the mechanism, how it will going to happen in detail, okay, and some of the CET NEET questions based on this, okay, and some of the important points for these reactions we're going to study, okay. So SN1 means what? So quite simple. 1 is unimolecular, N means nucleophilic, and S means substitution. So specially this SN1 reaction is unimolecular nucleophilic substitution reaction, okay. So it is alkaline hydrolysis of tertiary butyl chloride, alkaline hydrolysis of tertiary butyl chloride to produce tertiary butyl alcohol, okay. Alkaline hydrolysis means where the tertiary butyl chloride is hydrolyzed in presence of a alkali, or it is treated with a alkali is nothing but like a sodium hydroxide, which is a base, like potassium hydroxide. When this tertiary butyl chloride, which is an haloalkane, is treated with a sodium hydroxide or potassium hydroxide, which are prepared in the water, will result in the formation of a tertiary butyl alcohol. How? We saw these reactions in the previous chart or the example which I gave, okay. So there all we got alcohol has a main product. Here also we are going to get a main product. But how exactly the reaction is going to happen, that is what the mechanism we are going to study here, okay. So here tertiary butyl chloride, I'll just write the reaction. See, what is the condition for the tertiary? 0 hydrogen atom will be attached to the carbon and the 3R group will be attached. This is called tertiary butyl chloride, okay. When it is treated with the alkaline solution, that is sodium hydroxide, okay, it results in the formation of, as I told, carbon will be the positive charge, chloride with a negative charge, which is a weak nucleophile. We have Na plus OH minus. This OH minus is a strong nucleophile, will replace the chloride atom. So it results in the formation of what? CH3 and CH3 over here, CH3 which is a tertiary, and OH will be substituted, tertiary butyl alcohol, and NaCl will be formed. This is how the reaction is going to happen, okay. So this is reaction. Now how exactly will going to happen? What is the mechanism of the reaction we are going to study? See, so there is a reason of calling here as unimolecular. There is a reason behind this one over here. How? What exactly? We will study. Once we complete the mechanism, we will get to know why it is called unimolecular nucleophilic substitution. Okay. So, what is the step 1 of the mechanism? How exactly reaction is going to take place? The first step is formation of a carbocation. Okay, here carbocation will be formed. That is the first step. Okay. What do you mean by carbocation? Carbon with a positive charge. How exactly it takes place? See, here we have tertiary butyl chloride. Okay. So when this tertiary butyl chloride undergo a reaction, okay, it undergo heterolytic fission. What do you mean by heterolytic? Carbon and the chloride bond will break unequally. The unequal is reason because the chloride is highly electronegative in nature. So what happens? The bond breaks unequally, okay. This breaking of the bond is the slowest step. Means the reaction will take place in a very slow way, okay. So it results when the bond breaks unequally, carbon will give out all the electrons to the chloride and will going to attain a positive charge. So we will going to get what? Carbon with a positive charge, okay, and we have a chloride ion here, okay. This is the slowest. This breaking of the bond will not take all of a sudden. It takes a time, okay. That results in the formation of a carbon with a positive charge. This is we're going to call it as a carbocation, okay. Since it is from the tertiary butyl chloride, we're going to call it as a tertiary carbocation, okay. So this tertiary carbocation okay, is highly stable in nature. It is highly stable in nature. Its stability is increased in presence of a polar protic solvent. What do you mean by polar protic solvent? For example, since we are carrying out the reaction, we need a medium for this. Okay, so for that reason I can do this reaction in presence of a water which is polar in nature. I can carry out the reaction in presence of alcohol which is polar in nature. I can carry out the reaction in presence of a carboxylic acid which is polar in nature. Okay, so what happens, since this carbocation is formed, the reaction is reversible here. Means once this is formed, can again combine with a chloride atom and can give back the tertiary butyl chloride very easily. This is reversible. So for that reason, this need to be very stable. Okay, means we need to make it not reactive with a chloride atom, not to go backward to its original reactant. For that reason, when we use this polar protic solvent, okay, it gets surrounded, means surrounds this carbocation formed and it stabilizes. Okay, so that the reversible reaction is stopped here. There is a main reason for the use of this polar protic solvent, which will going to stabilize the carbocation formed. Okay, now this is the first step. Okay, the second step is that, so step 2 is attack of the nucleophile. Attack of nucleophile. So which is a nucleophile here? As we studied in the reaction itself, OH minus is a nucleophile. How it OH minus came? So it is from NaOH. Okay, so this nucleophile, which is rich with the electron, will try to attack the carbocation formed. CC, CH3 and CH3 and CH3, carbon with a positive charge. When comes in contact with a nucleophile, this nucleophile hydroxyl ion combined with this, okay, and immediate reaction takes place. Okay, CH3, CH3 and OH. Okay, so this is what the required product, and this is the first step of the reaction. Already the carbon is with a positive charge available. When the OH minus is produced immediately, these two will combine and gives tertiary butyl alcohol. This is the fastest step of the reaction. Okay, so it is 2 step of the reaction. This is how we are going to get. Now, in the first step of the reaction, it is the slowest step. If I want to determine the rate of a reaction, here the chemical kinetics part will appear. If I want to find out the rate of a reaction, I'll go with a step which is slowest one, so that I can find out at what time the reaction took place and what is the speed of the reaction. So in the slowest step of the reaction, nowhere you will going to find the nucleophile here. Do you have the participation of a nucleophile in this step? No. So the rate of a reaction is directly proportional to the concentration of what? Concentration of only alkyl halide, because in the first step only the alkyl halide is involved, no nucleophile. So since the rate of a reaction depends on the concentration of only the one reacting mixture or only one reactant, so it is the first order kinetics. Okay, first order mechanism. This is how the reaction takes place. Okay, slowest step, first order reaction. Okay, next one is, and that is why we are going to call it as a unimolecular nucleophilic substitution. Unimolecular means the rate depends on the concentration of only the alkyl halide, not on the nucleophile. Okay, next comes the order of reactivity. Means here, instead of taking the tertiary butyl chloride, if I take the secondary alkyl halide here, if I take simple methyl chloride here, will the reaction takes place? Yes, the reaction will take place, but tertiary butyl chloride or tertiary carbocation formed is more stable, more reactive for the SN1 reaction than secondary than primary. Okay, so the order of reactivity is that tertiary will react very easily for the SN1, followed by secondary, followed by primary, and the two followed by For example, methyl halide. Okay, so tertiary is prior to the SN1 reaction, then secondary, then primary, then methyl halide. Instead of this one, if I take allylic halides, for example, CH2 double bond CH, okay, CH, and here I have CH with X over here, okay. So this is called allylic halide. So compared to the tertiary and the allylic halide, which readily undergo SN1 reaction, if the question appears, it is the allylic halide which readily undergo. Why? Because since this halide comes out easily, this will become the carbocation. This carbocation is stabilized by the resonance, means we have a pi bond over here. This pi bond moves here so that it stabilizes the carbon with a positive charge. Okay, so due to this resonance movement of an electron, this allylic halide is more reactive for the SN1 than tertiary. So before the tertiary, I can write over here the allylic carbocation. So this is all about the SN1 reaction. Okay, what are the reaction condition, how the reaction takes place,